Good day, the Dell ETF team. So our team and I will present our project, which is a multi-sensor system to predict early signs of spinal diseases. This is a table of content that we will follow for this presentation. We'll start off with an introduction. Then we will move on to discussion of some of the previous works. And from that, we will show how our project is going to be different from them. Then we will show some of the technologies used, the applicability of our project, and then the social and industrial impact. After that, we will show a video demo of the current progress in our project. So let's start with the introduction. Um, We'll talk about our motivation first. A large number of employees are currently working desk jobs either in their office or at home, and a majority of their work is done while sitting on a chair. An improper sitting posture, especially for an extended duration of time, can negatively affect the structure of the person's spine, which can further lead to spinal deformities. And then from our next point, we can see that an estimated amount of $87.6 billion was spent between 1997 and 2013 in surgical procedures concerning lower back and neck issues. So we need a way to detect these issues before it becomes major. To do that, so the aim is we want to detect early signs of spinal conditions such as kyphosis or turtleneck syndrome that can occur due to improper sitting posture for an extended duration of the time. Which means we want to find a solution that helps mitigate these problems by monitoring the user's body posture and sitting behavior. And then we want to report back to the user the condition of their spine with any potential of them suffering from these diseases. So what are these diseases? So in the first picture, we can see kyphosis. Now, kyphosis is an exaggerated rounding of the back. Now, people with kyphosis appear to be slouching or have noticeable rounding on their shoulders. Now, what kyphosis does, it leads to excess pressure on the spine, causing pain. It might lead to difficulties breathing or more pressure on the lungs, etc. So what is turtleneck syndrome? Now, in turtleneck syndrome, the muscles and joints become stressed as they work harder to hold your head in such an angle like the 60 degrees and 45 degrees. Basically, if left untreated, the neck can become like a precursor to more serious conditions like arthritis, curvatures of spine, discompression. So we want to detect this syndrome before it becomes a major issue.
This project proposes a solution that involves a multi-sensor system attached to a chair that can monitor and collect data about a person's posture and sitting behavior, and is able to analyze this information in order to classify between different body postures and identify ones that may lead to spinal disorders. The posture can be monitored using flex sensors. The classification system has been tested using algorithms like KNN, support vector machine, and random forest. The best performance we have obtained so far from our test was using the random forest algorithm. We are planning on implementing a time series regression model into our project as well, which can predict the change of a user's spine over a long period of time. The reading collected then can be aggregated and analyzed to determine if the user has a spinal disease or is in the early stages of getting it. We will now discuss some of the previous work that has been done on similar topics. In summary, some of the papers like paper 1 focus primarily on posture detection without prediction of spinal diseases. Paper 2 and 4 detected spinal diseases by running machine learning algorithms on just the data obtained from large datasets. The data from these datasets was collected via sophisticated equipment such as X-rays and MRIs. Other papers, like paper 3, have focused on collecting data from participants through sensors that are physically attached to the user's bodies. These papers either use posture recognition systems alone, or they use datasets alone to classify diseases. If they tried to attempt both, they used intrusive methods like sensors attached to the user's bodies to measure and classify readings. So, how is our project different from others? We are planning on using a non-intrusive design which means our system does not use MRIs or X-rays. This can decrease the cost of producing our final product, which means it can be scaled for multiple users at a lower price bracket. Furthermore, as, as, as the sensors are not attached to the body, this means that the user's movements are not hindered in any way while using the smart chair. They can go about their work doing the tasks needed, and the chair will collect data when they are sitting on it. Moving on, our system will be able to predict a spine disease instead of just posture detection. We will also have an assistive 3D model of the spine that the user can interact with. This model will also be very helpful for doctors for preliminary diagnosis. The cloud server allows for further scalability of the current software infrastructure.
The main hardware that we implemented consists of the Raspberry Pi that collects data from the Flex sensors and sends it to the cloud periodically. Additionally, we have 7 core software platforms that we use. The first being Python, which we use predominantly for programming with the Raspberry Pi. We're also running a Flask server, which also uses Python in the backend. We have HTML, CSS, and JavaScript running on the front end of the web app that the user interfaces with. We also have Bootstrap for the templating of the front end. And finally, on the front end, we also have a specialized JavaScript library called Chart.js to present graphs and other charts to the user. In addition, we have R as a programming language that specializes in machine learning, and it is what we are using to create all our predictive models. Finally, we have Microsoft Azure platform running on the cloud in order for us to send data from the Raspberry Pi and send it to the user. We believe that our project has 2 primary applications. First, the user will be able to use our system to keep track of the sitting behavior and posture in order for them to keep tabs on how healthy the sitting behavior is and make changes accordingly. Secondly, doctors can utilize the 3D spinal model that we generate through the application to provide them an indication of the patient's spinal health in order to help them with a preliminary analysis of the patient's condition. Furthermore, we believe that the applicability of a project can provide massive contributions to the way people view the spinal health and posture. The early diagnosis of spinal diseases can help patients to seek medical attention early and help prevent them from increasing in severity. We also hope that the use of the spinal model will catch on within the medical community and, provided that it is accurate enough, help doctors with mild cases that require less attention. Here's our references. Moving on to a short demonstration of our current progress so far.
The dashboard that the user sees. It contains the important information that is relevant to the user, like the duration of good posture or the longest period of sitting. And below that, you can see a graph showing the hours of sitting per day for the previous week. On the side, in the menu, you can see the different options that are available to the user at different screens. One of them is the statistics page, which contains more information. So here you can see the overall spine health score as predicted by the machine learning model, and you can see comparisons over 2 different months, and you can see the values for particular days. Below that, you can see an overall variation from the previous month, which will indicate any major changes to the user's spine structure. And below that, you can see the average stability per seating session. So this would indicate things like fidgeting or restlessness. Finally, we have a 3D model of the spine, which can be useful in diagnosing whether they have major deformities to the spine structure. Then there's also the option to see it in augmented reality. So you can select a flat area in your surrounding and see the spine in AR in real time. And finally, the user can choose to log out, which takes them back to the initial screen that they see before pairing has been completed, which requires them to scan a QR code on the chair, as you can see here. And once the QR code has been scanned, it asks them to, it shows that pairing has been completed and takes them back to the dashboard.